Good evening, everybody. I am here with Mr. Dane DuPont.
Yep.
And Mr. Anthony.
Hi, everyone.
So we were just gathering to give you guys a short update here. After our evening at the hub, we had a community dinner again tonight and another afternoon of passing out supplies to evacuees. So we are now kind of gathering after our community dinner, and it was great to see some of the old faces, coming back around to the hub and talking story about how things are going and the next steps for them to kind of get their livelihoods back in order. So that was a great evening. So we're a little late with the update for you guys tonight. There hasn't been a huge amount of developments signal-wise, but we'll go over what we have for you guys here tonight. So,
just dive right into it, huh?
yeah, without further ado, let me pull up maybe the tilt
Yeah, let's start
first.
in
Get
the datas.
get this lined up for you guys here. All right. So, here is our. Let's see if I can lean this on something. Like find a pointer.
Makeshift one.
All right, guys. So here's our week-long plot showing both the summit and Pu'u'o. You guys can see that overall it's kind of flat. There's a little hint of a rise right there, right? Our scale is 2 microradians per dashed line, right? So we're looking at from -1 to about +1, about 2 microradians in the last 1 week or so.
Yeah, 1 week.
Come on, focus. There we go, focus. All right, so in the last week, we have a very noticeable spike right here that happened, I want to say it was just before 2 a.m. yesterday, maybe 1:40 is maybe the time of an earthquake that I found that was actually a 4.0 down in Loihi. So we'll talk about the earthquakes here shortly as well. Maybe just jump to earthquakes now, huh? Since that's kind of a relevant thing to tie it all together. So take you guys to the earthquakes here, and let me reload here. So we're looking at right now the last 1 day, all magnitudes, and there's not a whole lot of activity on the island, but let's bump it up to 7 days and make it update. Where is it? Okay.
It looks like they actually changed the magnitude on the Loihi earthquake, the 4.0, now 3.9.
3.9, oh, that's so I made it a slightly smaller circle on there.
Mm-hmm.
Right, so okay, so basically, to kind of talk you guys through the earthquakes. We have our summit signal up here. Let's zoom in here. We have our summit collapse. Oh, we got a screw today, the screw pointer, yes. There's our summit settling earthquakes, right? It's not exactly collapsing in the same way anymore, but appears to still be settling, adjusting to the changing volume underneath there. It's hard to say from the tilt exactly whether it was a net gain or loss right there recently, but basically it's still going to be adjusting for a long time afterwards, just like the south flank, which is kind of over here, this area south of the rift zone going on, right? So all these south flank earthquakes are still kind of aftershocks of the 6.9. There's a small cluster right up here, right on the rift zone, which are kind of shallow, but there's only 4 of them. They were yesterday. If that were something that was continuing, we might be on higher alert that there might be something happening on the rift zone somewhere around there, but with just 4 earthquakes, it might have just been something more localized, not as concerned that it's en masse movement of magma towards the surface.
Mm-hmm.
We definitely know the magma is down there under that area. It's always under there. It never goes anywhere else except onto the surface, and basically after it's done erupting, it just sits under there until it's time to erupt again. So it doesn't really ever disappear, it doesn't drain anywhere else, it's kind of always underground in that area.
Yep.
Something to add with that, Dane?
Yeah, I mean, basically right now, like what we're looking at earthquake-wise, we're, if anything, in the last 24 hours, last 48 hours, we're slightly below average, statistically speaking, but it's within the observed norms since the pause. There's been a small amount of earthquakes on the south flank. There's been a small amount of earthquakes on Pahala, slightly more at Halemaumau. And that's just the basic trend, and the numbers that we're looking at, just the magnitudes, the locations, pretty consistent with what we've seen or come to expect at this point.
Right.
Looking for anomalies, this is far from an
Talking
anomaly.
to John Stallman this evening, I asked him about the movement of the flank, thinking that 20-inch, that big 20-inch movement, or not so big as I was told, but movement was like just a one-off. But he was suggesting that it's still going and it's still moving away.
Yeah.
Yes, indeed. Yes.
How do these earthquakes actually in that particular part of the rift zone? How does that relate to that movement?
start?
Or can it relate to that movement?
Yeah, go ahead, Dane.
Well, layman terms.
Yeah.
South flank, anything around basically this area that's between 5 and 7 kilometers deep, you're going to associate with the south flank in there. The USGS has classified all those south flank earthquakes since the 6.9 as aftershocks, and the aftershocks can last a very long time as the ground settles and as the kinks in the expansion, the rift opening, the kinks are all kind of worked out. After that process, which we don't know how long would last, then they might settle, but probably not. The flank just stays pretty active.
Okay.
Even looking back historically, it's
But are earthquakes in that area then related to that movement, or are they unrelated?
related.
Yeah,
They
so
are
these,
related,
these
yes.
earthquakes right here are actually indicating
Related
movement
to the movement of the flank.
Yeah, movement of the flank past some bump where it actually is catching and sticking and having to overcome that obstacle.
Got it.
We actually have what we call slow earthquakes that I haven't heard reported in a while, but these would be events where in the course of I think 24 hours we might have a similar offset, on an order of half meter to a meter in 24 hours, which if it happened within 24 seconds, we would have called it a 6-point-something earthquake as far as how much energy it would release. But the fact that that happens aseismically, kind of creeping over 24 hours, accomplishes the same end result without the earthquakes.
Without the earthquakes.
So it's kind of all about whether it sticks or not, rather than whether about it's moving or not, if that makes sense. It can kind of move all the time. It can only stick sometimes, right? So like if it's actually stuck on something big, that's the kind of situation where it can lead to some instability, like needing to have a 7.7 earthquake in 75, or needing to have a 6.9 earthquake this year, kind of thing, where where clearly you overcame some big obstacle that was holding it back to allow it to move that much.
And John also mentioned that the whole island chain is unstable anyway. So the 6.9 for Hawaii is a lot worse than a 6.9 on the mainland, was kind of the way he expressed it. Does that make sense?
Yeah,
Because of the instability of the what's the island chain, right?
Yeah, mostly. I mean, there's a lot of factors that go into that, right? I mean, I don't think a 6.9 is really good anywhere, right?
Right. Yeah.
And
and there's the whole, how far down is the epicenter and all that kind of stuff, right?
Right. And there's also, the community aspect of like how does a community actually build your buildings, right?
Yeah.
Because historically, like 6.9s in Turkey
I mean,
kill hundreds of people.
there was a 6
Right.
point.
Sure. Yeah. What a
I
way.
think there was a 6.3 just within the last week, and I want to say Thailand. I know there was
Okay.
one in Papua New Guinea that was larger, but the one in Thailand, it was relatively, small comparatively, but there was loss of life there. The 6.9, or the larger one in Papua New Guinea, there wasn't. So, as you're saying, where it takes place, the epicenter compared to the populations, building codes, all that plays a factor is in how dangerous is it to the population.
Right. So I mean, it kind of comes into the issue of what we call like hazard against risk, right? So like the hazard maybe is larger because of the instability, right? So we're likely to have that kind of earthquake regularly. But the risk maybe not as much as other places, because we typically build out of wood here. Wood is the best thing to build when you have a lot of earthquakes, because the wood can bend and adjust to the movement of the ground, right? As opposed to, for example, a mud hut in Turkey, right? That's kind of one thing, right?
Yeah.
Also, areas that have earthquakes commonly are usually more prepared for them, right? Japan is a great example, right? They have it down, right? Thailand, on the other hand, does not have earthquakes very often.
Yeah.
Or Cambodia, right? That's why I was lucky to be able to go and visit a lot of those local temples. Why do you have a 600-year-old temple still standing under wasn't built with mortar.
Right, and it's a
Because it hasn't had earthquakes that many times over that period of time, and when you have them and you see the things fall down, it's like, okay, well, that's how frequently they happen, or infrequently they happen, that the structures are still standing
definitely
hundreds of years later.
Yeah.
So when it happens there, no one's going to be expecting it or practiced at it,
Yeah.
and it's a whole other
Yeah.
can of worms. So the risk is a way more complicated thing than a hazard. So I totally get, the hazard part. Yeah, absolutely. The islands are absolutely unstable, like things are moving all the time.
Right.
But, kind of similar to what we were talking earlier, totally unrelatedly, is that, Hawaii does have a lot of different natural events,
right. And one thing I
total
would
disasters possibly. We had a lot of practice at that, so
Okay.
maybe that gives us a little bit of
and
an edge.
it applies to everything. Like it's the same for type of hurricanes. So some areas are more prepared for hurricanes. So like you compare the Philippines, for example, they get battered pretty persistently with strong
typhoons,
winds,
yeah.
typhoons, all those come in. You send one of those to Puna, oh man, we're not ready. The trees are too weak. They're too tall. They're just wind blocks. It'd be a Zell, times 10. And so, they may, some areas might not be, suitable for earthquakes, but they're really suitable for other types of disasters. And it's just, like a variable scale. So it's not just like, oh, that place is, not prepared. They're prepared for other things.
But relating it back then to the 6.9 here in relation to the flank movement and what you said was, rubbing up against something, something that kind of blocks it, gets in the way, and then it needs a 6.9 to like
Free it.
Yeah, right. That's kind of what you were getting at.
Right. Yeah.
With regard to the flank.
Yeah.
movement.
As that rock goes over that bump, whether it actually physically breaks the bump or like something happens that actually scrapes across it or what have you, like that releases energy.
Yeah.
And that's where the energy for earthquakes basically coming from. And if you had it nicely lubricated in a slow earthquake, you would have the same movement without any of the shaking. The flank moving just as much.
And I think, Dan, I tried to ask you this the other day. Forgive me if it's a repeat. You probably covered this on enough that I didn't watch.
No
but
worries.
the epicenter depth of this one was determined as how far down?
Which one? The
6.9.
6.9. I forget now, but I want to say it was in the range of 8
Kilometers?
something like that. Yeah, something like that.
Right.
Within the stack, right? And there's actually, I think of it as like a series of layers, like almost like pages of a book or a stack of magazines maybe, where they're not bound, like they're all loose. So you actually have discrete sliding zones that are not all at the same depth. They kind of stack.
Right.
But certain ones move more frequently. But just because then the bottom one might move, it might actually trigger a succession of shallower ones to have to adjust as well. Right, like a sliding magazine is sliding off, and then the bottom, the one at the bottom is sliding, and all the ones above that are also going to shift slightly.
Okay, I get it. Interesting
If that
analogy.
makes sense, yeah.
Yeah, okay.
Often
5.8 kilometers.
5.86 kilometers. Yeah.
Whoa. So that's considered pretty shallow, right?
That would be in the flank zone. The
It's
south flank.
it's within the edifice of the volcano, So I mean, it's not shallow for us, obviously, as people, but it's typical of where the south flank is actually sliding. It's deeper than the magma moves through the earth, which is it's deeper than the shallowest plains where it moves through the earth, right? Because it can move from great depth, kind of coming up and through.
Right.
And especially in this area, it's deeper than we think the magma is moving all the way through there, which is between maybe 1 and 3 kilometers down.
Okay. All right.
Half mile to mile
So
and a half,
underneath
more or
that,
less. So
basically.
below that, right? Below that, an offset to the south.
Yeah.
Right? And that's kind of why when I look at this map of the earthquakes, I want to look at not just the ones on the rift zone, those are possibly rift zone with a dike. Actually, this might be something with a dike, possibly. But everything south of there, especially once you go in and check and see how they're deeper, is basically this thing getting pushed and that whole wedge moving towards the ocean there, right? And the thing is, we might think of this as like one giant, thick, coherent domino piece, right? It all moves as one big block. But actually, it's like all these different segments of it. And it doesn't move it's not a rigid piece of land. It's a piece of earth with lots of cracks in it, as we all know, right?
Yeah.
So it can actually move in different sections.
Right.
It could also do some little bit of pivoting.
That's what I was thinking, yeah. So one part might not move as much as another part, or not at all in relation to the other part.
Yeah, especially when you look at this interesting geometry right in here, which is, this is a southeast rift zone right here. It actually goes east-northeast. And this section here, it goes east-southeast, right? It goes from the summit, southeast, then it turns east now, northeast, right through there.
Yeah.
So we have this big bend, right? The southwest rift is different, it's just straight,
Yeah. Okay.
right? So when you have this big bend, right, and you have this line of, this set of cracks in between the two that kind of connect them. So the south flank is really like from here, this strip over here, and doesn't include it. From here north is basically the summit. So when you move this piece of land there, right, you actually open this piece of the rift zone, but not this piece of the rift zone. Right? The geometry kind of swings it around. So then when you kind of pressurize this part, you might push this part out, but kind of pivot it around the other way. So, you know, that's like if we, you know, try to imagine particular scenarios, being, you know, not knowing, all I'm trying to show is the complications which can exist of how it might actually move separately. You know, one thing that
Yeah,
we've
the
been
interactions are very
discussing.
complex potentially. Yeah.
Yeah, we'll get back to the GPS and tilt. We can kind of see that, you know, there's not a whole lot of signal of anything happening with, you know, the ground moving farther down, you know, from 130, but there is some indication of ground movement up here, which, you know, may be chicken and egg once again. You know, is it the magma pushing? Is it the south flank pulling? In either case, it allows space that magma can fill the space, can increase the heat. We can kind of keep seeing the gases coming out, all those patterns that we're used to seeing over the last, you know, couple months or so.
Yeah.
And so the question, you know, really is, if it really is the south flank that's kind of driving things, you know, is it going to create a pathway for magma to come to the surface by moving out of the way, right? Or is it going to just kind of make space, and then magma comes in and makes more space, and it can never catch up? Impossible to predict that, right? You know, unless we have some good number on a supply rate from below, and a good rate and the amount of the flank moving, and how those things relate, and whether they're somewhat constant. That's just too many variables.
And remind me again. I think you mentioned it last time, but how do they measure the flank movement?
GPS.
GPS.
Primarily, yeah.
So we can maybe show this. This is all the earthquakes that have happened since the eruption began until today on the south flank. And you can see this trend right through here is primarily where it likes to get. And when you start checking these, they're all going to start being in this range. They're all going to be like 5.6, or except for the one I click on, of course. 5.8, 2.5.
Yeah, there's all over them, yeah. But there's kind of
They're all over.
two patterns, right? So like this trend down here, like that's the south flank ones. This one up here, that's going to be the Leilani actual rift zone
Yeah, up here
patch,
all
right?
around
And it's
now.
kind of cut off because just how Dane drew the box to ask for the earthquakes.
Yeah.
Just so you guys can follow us there. So yeah, so the south flank earthquakes are nothing new there.
Yep.
Maybe let's move on the earthquakes. You know,
Alright.
we have Mauna Loa earthquakes that have been happening. There's been like maybe one more in the last day, but that's still not a strong enough pattern to say that it's eruptible. You know, the mountain is moving. There's magma moving within there. I would say, pretty confidently. It's not near enough to surface that any tilt meter or GPS is detecting it. Mauna Loa is a massive, massive mountain, so that there's plenty of room for magma to move around inside of it without actually coming out to the surface. So, any movement of magma within it is definitely something that we take notice of, but doesn't automatically lead us to start panicking towards an eruption. We need to see that kind of consistently, do that kind of pattern for a while, show some kind of, longer term trends, show some surface signals, whether it's tilt meters or whatever else you have, gas emissions, heat signatures, that kind of thing, to actually let us believe that something is working its way towards the surface. So,
And one asterisk about that location and depth, if you look historically at the seismic records of that area of Mauna Loa, that's going to be the second most the most dense area of earthquake activity. The most being slightly to the south of that, a few miles. But when you see it in a common location like that, at a common depth, it's hard to extrapolate much from that.
right. So let's just kind of, summarize it as like, interesting, but not super concerning for Mauna Loa right now. Obviously, it's something we're going to watch, and if more happens, we'll shift our attention there more directly. Our Pahala earthquakes have kind of slowed down a little bit, but they do still kind of happen. A few in the last week or so. One more recently here on the left side. But really, the story that I'm trying to get to is these ones down here. This is so I actually have on my setting. I'll show you guys. how I can see this. On my settings, I show map layers. I put it on terrain instead of the grayscale, right? And that actually shows the fault lines. So what this is actually showing is the summit caldera fault of Leilani and its 2 rift zones. Right there, I believe, is what those actual lines are.
Makes sense.
So you guys can see that this cluster of earthquakes is actually on closer to the southern rift zone, but close to the caldera of Leilani. These are actually all Leilani earthquakes. And this is kind of a similar pattern as Mauna Loa, right? We actually see, what I would call a cluster of earthquakes, right? That's different from what I call a swarm. A swarm is something where, to me, that has more implications towards an eruption. A cluster means you just have a grouping of them, close in time and space, but not enough to be a swarm, right? It's like a level below that, right? So this is not not concern of a eruption in Leilani. Even if it was an eruption in Leilani, there's not a whole lot for us to worry about on the surface when that does happen. And by the way, there was a much more intense seismic swarm in Leilani, I want to say in 2004, that did not erupt. And there was one in 1996 before that, which did cause an eruption underwater, and there was no kind of effect on the island from then. So, but interesting, just looking at the earthquakes, because of these ones, let me see if I can get a...
And sorry, this is still a 7 day?
This is still a 7 day, yeah, exactly, yeah. So, just because it's, the orange ones were the ones that kind of were showing our signal yesterday. So, yesterday, let me scroll down here on the left. There's that one right there that happened at just about 1:40 a.m. on the 14th. That's the exact time of our tilt spike, which is how I went down this earthquake road. So that's the blue one right here. It was listed as a 4.0 until just recently. Now it's listed as a 3.9 upon further review, which there's nothing wrong with that. They actually got in to look at the waveforms, the squiggles on a record, and made some better picks than a computer could have done, and that kind of is how they refine the size and location of these things. So it's usually because a human got involved and did better than the computer could have done automatically without supervision. So it's common for these things to move. There's no funny business going on there. It's just actually people coming in and saying, hey, computer, you could have done better here, could have done better there. Yeah. So basically that 1:40 a.m. is what causes this big signal,
spike,
right?
Yeah.
On the tilt, yeah. So you can see that it's actually evident. You can't tell so much from this double plot of pool and a summit, but you can see it. This is a 2-day plot at a summit. It clearly shows. Oops, touch this thing. There is the summit again. Escape Road shows a little blip. Down that Leilani, we don't. Well, maybe right there at the top of that. No, I don't think that's it actually. It's probably this one right here. Actually, it was at 1. It must be this one because it was right in the middle of the night.
Yeah.
So that could have been it right there. Not as convincing. And at POO, we actually don't see it at all. Which is, is that it? Maybe right there? It's
Yeah, that little knob.
Yeah, maybe that was it. But it's definitely, what's interesting is that maybe these 2 south flank, so we do see it on Jonica.
I seem to remember that when we've had these spikes in the past, they tend to show up on Jonica better than they do on the POO.
Yeah, which is interesting, right? Because the energy, so there's kind of 2 possibilities there. One is that there's actually enough fluid, likely magma, under Pu'o'o to absorb that. The other thing is that the actual block that it's on has enough, let's say if it has faults on the sides of it, that basically could dissipate the energy, right?
Not turn it into a spike.
Yeah, exactly. If like that piece of rock is not as solidly connected to the rest of the rock below it and around it, let's say it, right? So, it's hard to say just based on that, but you could say potentially a station that shows a bigger spike is better connected or has an easier path for the energy to reach it.
Yeah.
And if it was like across the island, you might say, okay, well, it's just location. But when you have 2 stations kind of close together with that different signals, you might start to suspect something else is going on too.
Yeah, and it's not just this one. I'm pretty sure there's other examples of that as well. That
Right.
trend.
So in any case, the tilt spike's not something to worry about as far as our current eruption now. It's basically just, energy getting transferred through. It's not transferred through as much as Pu'u'o, but that doesn't really affect the eruption potential at Pu'u'o at all. It's just kind of a curiosity for now. We are kind of searching for signals of why Pu'u'o is showing us a different signal than everywhere else, right? It's not, it's just one more observation to add to the arsenal there of something different at Pu'u'o. Is this lack of a propagation of the energy through that particular piece of the rift zone. So anyways, otherwise, from a continuing steady increase in tilt on a component of Pu'u'o, there's definitely something funny happening there. It's not clear if it's a buildup of magma pressure just in that one area, or whether it's the ground still tilting. Kind of leave that debate still, to be resolved by nature. Tell us what's actually happening down there, and just share that besides that, there's no real indication of anything major happening with the tilt. I'm going to add one caveat though, which is that looking at a lot of past eruptions, there are times when we don't see tilt signals preceding eruptions. So it may well be that the signal that I'm particularly looking for, the tilt signal, may not give us that good indication of what might happen ahead of time. So that's why we're trying to keep track of other indications, whether it's steam or heat or gas, especially is the one seismic as well. We'll look at basically those other signals to verify, to give some weight to any possible conclusion we might have with that. So
Definitely.
so let me show you guys the GPS here. Let's move the camera around. Show you the GPS doesn't show. I'll show you guys what there is to see. All right, so it seemed like there were some excursions, from our kind of steady average line here, and what we've learned is that some of these excursions are actually caused by weather blocking the signal, from the GPS receiver to the satellite. So that's why you have so much kind of built-in noise to the signal, right? It's hard to, I'm not sure that we can really say, okay, the ground is actually going up, what's that, 20 centimeters and then down again, and doing all that as opposed to, on a every few hour basis, instead of actually, having atmospheric interference is much more likely, with a GPS signal. So it's not quite clear to me what this over here is, right? This definitely looks different from the rest of the plot. This could actually have corresponded to that similar kind of, shaking possibly. It's GPS usually has a lot less measurements. It's not quite as much resolution and time, so it would be a little surprising to actually see the same kind of signal as like an earthquake propagating through the GPS, but there could have been some effect that just doesn't come to mind to me right now. Some kind of interference of some kind that.
Yeah, I mean, you're making a satellite link at that point, and if your signal gets weak, it can start to travel and keep propagating the last trend that it had until it regains the signal. I have no idea on how their polling works or what algorithms they have in the back, but just thinking out loud,
But that's today, actually, isn't it?
Yeah. And with GPS, there's a margin of error that just comes by being GPS. You can whittle that down a little bit, but there's still going to be that inherent uncertainty with it, especially when you start getting more and more precise. It starts to hamper how accurate your readings are. You can't dive too deep into it, so that's why it's really good over long periods of time.
Yeah, so the important thing, I suppose, is the average, like the median value, really hasn't changed, right? And that's kind of what to look at rather than this big deviation that happens right over here. So kind of just scanning that, you can kind of see, we have deviations. We're still basically holding our steady baseline. Here's the same thing. Here's our one-year plot of Kahuna. There's nothing much different there. Our plot of Pu'u'o, still shows this interesting signal within the last maybe about a month or so. Maybe not quite a month, huh?
Yeah.
not quite a month or so. So, you know, that's something we're definitely keeping an eye on, and, you know, that we can discuss more as well. You know, one thing that's interesting though is just kind of looking at this plot, looking back in time. This is kind of leading up to the eruption. This is when we have the ground moving before the eruption. So you guys can see like it actually was pressurized enough to actually move quite a bit before it actually snapped and really sort of relieving that pressure and contracting. And what we see
How
here,
far back to does this go?
It's a 2 year or
this one's a 1 year,
okay.
yeah. There's a 5-year one just below this, so I can show you.
Oh,
that.
okay, yeah. Cool.
Is it 1 year? Oh no. No, it's
I
not.
excluded the 5 year.
Okay, it's on the USGS page. I can show that to you later if you want. There we go. So anyways, what I'm trying to show is that what's happening in the signal over here is not our typical eruption pattern, right? So that's not to say that it's not something that would lead to an eruption, you know, for sure. It's a curiosity that's like, okay, well, you know,
This bit.
yeah,
Yeah.
that part right there at the end, yeah. What changed, you know, a few weeks ago?
Right, it looked like it was coming really close to steady signal at this point right here. I don't know
Right.
where my thing went, but
Nothing fell on the
yeah.
floor.
And then it takes that turn down. And that's like just about the beginning of the month. Just about, maybe a little before.
Right. So, I mean, I think the actual inflation at Pu'o'o might have begun slightly before that. Maybe slightly before. It's harder. I'll have to go back.
The
and
tilting?
watch. The tilting, yeah, that's what I
Yeah,
mean. Yeah.
it's
It might have preceded it a little bit.
yeah, it did. Have to,
So it's interesting, you know, that we have the ground tilting at Pu'o'o, and then right near there we also have signs of it moving, basically contracting around the rift at the same time. So that's kind of a curious signal that doesn't seem to. They kind of seem to be at cross indicators there of what's actually going on. So we're still kind of trying to decipher exactly what's going on there. But I suspect it's basically related to the interaction of the south flank and the magma coming in.
yeah. The tilt at Pu'o has been happening for a month.
For a month, exactly.
1 month, yeah, pretty much. 1 month tomorrow. Would be when I started it.
Right, okay, so and then if this is mid-October, this is a month and a half right here, right?
Yeah.
So,
Like October 1st-ish.
yeah, so it might be about the same time, yeah? Slightly
It's about
after.
there, a few weeks, I think, would be the difference. Maybe
Right.
1 or 2 weeks.
Right. So that's curious also, right? It's not exactly 1-to-1, but it's closer in time than anything else. So we're going to try to decipher that as well, you know, and it might be something where we really can't tell until after the fact what exactly this was showing, because we're still in the I don't know, obscure time where it's not clear what's actually driving
Right.
the game at this point. So that's basically the GPS. I can show you guys that we don't see any huge deviations in the trends. Right, we see the trends continuing. So like where it was rising slightly, it's still rising slightly. You can see all the different components. Nothing really has changed. You know, like for example here, where it was rising slightly, it's still rising slightly. Nothing has changed that dramatically recently. The change probably happened. This is probably what September-ish,
Yeah.
beginning of September or so. So I'll just kind of scroll through the rest of these for you guys. You guys can see, you know, here is a little noisier. It's not quite clear.
Here, 1 second. There are some of these that have a really small scale for the how many
Scale's
meters.
different.
Each.
Okay.
Yeah, the
Yeah.
scale's different on each of these. So there's a few of them that have like really small scales, and it looks like there's a ton of noise in the signal, but it's just such a
a
small
scale,
scale
yeah.
that's what's making the difference. This one, not so much.
Right.
But definitely we'll see them. The PGV one is one that's on such a small scale.
Right. Well, yes. I mean, I think, you know, just when we talk about like background noise, right? This is all before the eruption, right? So you can see there's a natural variation that occurs, even though nothing is. I mean, this was actually technically during a Pu'o'o was erupting during this time. But you know, as far as movement on the ground, you see there's actually a fair amount of scatter, which just occurs naturally just throughout the process, right? And we just want to be really careful not to say like, okay, well, this thing's way down, so therefore we're gonna cause an eruption. This is what's coming next, right? You know, so that's just want to make sure you see that second, third, fourth, fifth, through the 30th points, kind of continuing a trend before you say, okay, just the one is the one that's what we're going with, right? So there's certain areas where here and here you might see that's a lot messier. You want to be a lot more careful in that kind of situation. You just can't tell when it's going to be. And so, likewise in here, it's just not quite clear what this pattern is really going to lead to. But based on everything else, it's we basically can't conclude that any of the trends have changed. It's basically trending the same way, more or less, as before. Right? No obvious deviations like the ones we saw back in this time when eruption was actually happening, right? So, but there are times where you really can't tell eruption is coming necessarily, just that it actually is.
Yeah, there's nothing. It's a very sudden transition.
Yeah, in this case, yeah. If you go back to the Pu'o'o one, you kind of saw that was not the case, right?
Yeah.
Because Pu'o'o was where it was actually stuck, right? It didn't go past Pu'o'o and Riffso and it came out of the ground at Pu'o'o. So that would be like the key spot, the key indicator site because of that.
Right.
Right, so maybe you could see it pressurizing at that point, and then going, right? And then this station over here maybe is down a rift, so it couldn't have got pressurized.
I'd like to see some of the
rift.
data going back to when I was here last year in September, when there was quite a lot of inflation at the summit.
Notice on these are 2-year plots.
Okay, so yeah, September 17.
Yeah.
Right? I came here specifically because there was more inflation.
You'd be right in the middle of that graph.
Reports.
Right in the middle.
Not from these graphs, but just from the daily reports they put out, right?
Right. And then was it October we had a lake spillover?
Was it? I may have just missed that first spillover, and then there was another one this year, right?
In April. Yeah.
I wasn't here for the spillover, but I was here for it getting close to a spillover because it came
Right.
pretty high.
Right. So I think
Right.
I might have I may be wrong on this, and I've been here before
Okay.
the last time. But I want to see October.
Okay.
So maybe it was right like you see right after you came.
Yeah, maybe just after I left,
Right.
because I came late September, and the lava was clearly visible from Jagger
Right.
in the summit crater, which I had for a while.
Right.
So, that was one of the reasons I came over, because I'd heard about this inflation, being higher. I thought, well, okay, I might actually get to see the lava, in the caldera from Jagger for a change, right?
Right.
Because up at that time it was just glow and steam, right?
Yeah, absolutely. Yeah.
Right. Yeah. So, but I'm, as I look back to, what happened in the last 12 months, I do wonder whether that was, well, it must have been a clue as to potentially what was going to happen into the new year, and an early clue, an early warning sign.
The tricky thing about showing that to you is that,
Yeah.
like in our plots now, we're basically scaled out. The change that happened at the eruption start and since then is
Right.
much larger than anything that happened in that year
Right.
prior to that. The way
Okay.
that the plots scale the axes automatically,
Right. Make it look like
it looks like almost flat
Okay.
in comparison.
Right. Okay.
It wasn't.
Right. Interesting.
But on the plots that we have right now, we need to have a plot that we captured before this eruption to actually see the resolution that we need. And I might have one somewhere, but I just don't. I probably can't pull it up for you.
Well, that would be cool.
Exactly,
That would definitely be
this
cool for
moment.
me to see. To see
we'll see,
what happened from, third, fourth quarter of last year into the first quarter of this year, and just see whether that was indeed a clue. I mean, it must have been really, but I just haven't seen a plot to actually, prove it.
Right. Yeah. So I mean, generally speaking, Lava Lake has been high for a while, right? From back in that era, September, October. Kind of comes in pulses, so it kind of came
Right.
up.
Yeah, there was always inflation
wane a
and
little bit.
deflation,
Yeah, but even with so inflation cycles might have gone every 2, 3, 4 days. But you also had a several weeks, several months cycle beyond that, right?
Yeah.
Because it went high in October and didn't come high again until April.
Yeah.
Right. So
But it generally had this higher,
it was
inflation
kind of.
trend,
I think of it as like kind of
higher
oscillating,
highs and higher lows.
oscillating
basically,
its
kind of thing.
way up, right? So
Yeah,
like-
higher highs and higher lows.
exactly.
Yeah.
Exactly. Yeah.
Yeah. So there we go. Little did we know.
Right. Well, we did know, right? I mean, it's just like.
But as you say, when you now compare it to like what happened after the eruption and the scales, right? That's
Right.
the really
Exactly.
interesting
Yeah. Exactly. So I mean, oscillation was happening for a long time, years and years and years, right? So it took the lake not just spilling over, but it took the lake spilling over, and Pu'u'o crater floor uplifting, and a large crack on a west flank of Pu'u'o appearing, and the 61G flow all petering out in combination
Right.
to lead the issue their volcanic alert notice. I want to say April 17th, right?
Okay.
Full 2 weeks for the eruption,
Yeah.
saying, "Hey,
Okay.
we're so pressurized, we're about to burst." right? I'm obviously paraphrasing,
Yep.
but that was basically what the message
The
was,
message was,
right?
yeah.
Like where I was working on my app, more exclusively rather than reading updates every single day, suddenly I was reading updates every single day because it's like, okay, well now this is clearly all the indications we need to set the stage for an eruption. It doesn't always erupt after that necessarily, right? That's the 24 example where, it moved through the ground, everything except coming out of the ground. It's the only difference. But, the
So
ground.
was the 6.9 earthquake the catalyst for it? Or
I don't know
was
if it was the
Chicken and the egg.
6.9.
Yeah, he's still debating the catalyst or the chicken and egg, right?
And this eruption, you mean? The 6.9 or compared to 24?
Whether the 6.9 was, like you were just saying, it was like the pressure buildup and it was like about to burst.
Right. So kind of to recap the sequence, the 6.9 was actually like, so I call this like the 1-2 punch, right?
Yeah.
Mm-hmm.
The first punch, so we have pressurizing everything. We're basically like,
Yeah.
winding up
Yeah.
for the first punch, right? Is the lava lake
Yep.
coming up, spilling over, the crack forming, the crater floor pool rising.
Yep.
There was a 5.4 that happened
Then,
on
okay.
April 30th.
Okay, yeah.
That's the first punch. That's when the diaphragm pool moved all the way to under Leilani, right? And opened a pathway for magma from the summit that was moving pressurized pool to actually start following behind it. Now I described how the rift zone has a bend, so the pressure doesn't exactly immediately work its way over there. And I think it took 5 days until May 4th.
30th to the 3rd.
May 4th was the 6.9.
Yeah, the first eruption in Leilani was the May 3rd,
Right.
so we had the intrusion and then the...
Right. So, but there's a little complication in there, right? Which is like, once we form those first cracks, the magma that was already underground then has a path to escape.
Yeah.
So the first lava out was not pool lava; it was lava that was under Leilani for the past 60 some years,
Okay.
right?
Being pushed
Longer,
by the pool over
actually,
lava.
Yeah. Not even being
even.
pushed from its own internal ability to
Pressurization.
rise
Okay. Yeah.
from a crack that's now suddenly above it,
Okay.
right? So it's sitting there fine,
Okay, got it.
then there's a pathway suddenly. The gas has been coalescing over that time, and suddenly the gas is trying to go out. That's the first thing we saw was gas.
Yeah.
And eventually, the gas mixed with the lava starts bringing the lava with it, right? The gas is probably at the top, I imagine, like it's just going to come out with not as much lava. And then as the rest of it starts going, how comes the lava as well? So your pathway's open to the surface now, but it's not necessarily coming from pool yet, right? Pool lava came and pushed that stuff out eventually. That's when we saw fissures 19, 20, 21, 22, 23, I think, were the ones that really marked the beginning of pool lava.
Yeah, I
I
think that's
mean,
what
really-
John said at his talk the other day. Yeah.
Really,
Was
the
it?
change to me would be on May 18th. That was the day where we saw the fissures uprift 2022 reopen.
Yeah.
And it was a much different game at that point. in
Yeah,
time.
exactly. That's exactly what I'm talking about. Yeah.
Yeah.
I don't remember the date exactly. Yeah. So, anyways, that first lava was not the pool lava, and it was not even the Kīlauea lava wasn't even involved.
Yeah.
So
and-
I feel like when that lava made it around that big, like when enough of it came around that bend,
Right.
and now is able to move parallel to the south flank,
right.
now we have our 6.9.
Yeah, but there was some interesting times in that beginning part, like when there was an actual pause that happened. A lot of people forget about
2
in the
days,
beginning. Yeah,
yeah.
the 2-day pause where there was no lava. It it came in Leilani. It had put up its first, I don't know, dozen fissures, something like that.
And which day was that again? Remind me.
This is in the first few weeks. This is up until
May.
this is prior to 17.
Oh, prior to 17.
Prior to 17.
Oh, okay.
So then
Yeah,
what
so-
we get is an earthquake swarm, a true earthquake swarm, located, as Philip was saying, about a mile down. Roughly a mile down, and then it's just localized earthquakes, and it was all around Noni Farms, behind PGV, and at that point it was like, okay, something's coming.
So that must
Because
have been when 16 woke up and then died down
it was
for
prior.
a day or two, and I remember thinking, because I was right next to 16 at the time, I was thinking, oh, this thing can't make up its mind. 1 minute it's erupting, and the next minute it's gone quiet. And then there was like, a day went by, and we were like, oh. And then suddenly 16 woke up again, right? And then 17 happened shortly after that.
Yeah. So I kind of feel like the pattern was a little bit repeated.
Yeah.
So once the magma starts coming, propagates that crack that 69 happens, now we also have new cracks. And we have, once again, old magma is able to come up, being pushed. Now the pathways are more open, so pool lava is coming right behind it. It didn't take long after those 16, 17, 18 to open up for it to start switching over to pool lava. That was actually much quicker than it was the first time.
Yeah.
Right?
Okay, right.
So there's a lot more to the story than that, but that's the only relevant parts. We probably should leave it at that to
not dive into
not lose all you guys, without some kind of
whoever's left.
visual, reference, kind of how the sequence actually goes. But basically, in recap, 1-2 punch, the 5-4, followed by the 6-9 a few days later. That's what probably really opened it, right? So, but without that first crack to allow magma to move towards Leilani, you don't make the space for the summit to allow it to come down to cause a second one. So, and then that obviously is what led to the magma draining.
Yeah.
If that second one hadn't happened, it would have been a whole different dynamic, obviously. Wouldn't have a summit collapse. And, well, at least not this time. It would have happened sooner or later, right? If it was that for sure, that ready to go, But it would have been slightly different.
Okay.
So
the beheading of Pu'u'o is the other word that was constantly used. Still agree with that as a theory? It's now beheaded.
Well, so I believe that was referring to the actual lava flow that was going down towards the coast. So the flow itself was beheaded, right?
No, they actually mentioned it's specifically related to Pu'u'o.
So what I mean is that the flow was coming from Pu'u'o to the ocean.
Oh, you mean the 61G?
61G.
Yeah, okay.
Right,
Yeah,
so I don't know, and from what I remember, at least the way I read it, that's what got beheaded was the 61G flow.
Yeah, okay. That's
rather than Pu'u'o itself, right?
Okay,
It was like,
right.
So cut off at the source, the flow kept moving for a couple weeks maybe. I don't remember exactly anymore. Typically it's a couple or 3 weeks, something like that. Is how long those things can be beheaded and still kind of ooze. And then after that,
gone.
Is
Yeah.
Since then it's been collapse of Pu'u'o and a lot of gas coming out of there, right? So that's interesting still. It's still noteworthy to see all the gas coming out of there. It doesn't necessarily by itself mean that magma's going to come out of the ground there again, but it's definitely still in there, right? It doesn't go anywhere, it doesn't drain away. What it can erupt again is a whole other question, right? And that's kind of back to what's driving the car, right? Is it the rift zone? Is it the magma?
Definitely.
And I don't know.
Right. That old debate yet to be determined, basically.
Yeah, and maybe it's both.
And maybe it's a little bit of column A, a little bit of column B, kind of like the collapses and the surges at Fissure 8. You get the ones that didn't show up, and it's like it's not absolutely related to the point where it's coming no matter what, but it's related still, and you're kind of debating how related is it? Is it just one of those debates that's going to be interesting academically going forward?
Right.
Okay, cool. Yeah.
All right, so have we beat the GPS horse to death yet?
It's done.
So, all right. Let's move on from GPS. And so we've done the GPS, we've done the tilt, we've done the earthquakes. We don't really have a whole lot as far as webcam images to show you guys. There's not a whole lot to show you, really. Is anything different. We do have some images of the fissure, of the steaming area, kind of uprift of the fissure, right? So one thing that we've kind of noticed, and John's talked about a lot, is how the USGS reports don't show any indication of anything happening beyond 130, but there are indications of something happening above 130. So we kind of mentioned, in passing how it seems like the actual, let's call it a pinch point, or the zone beyond which the deformation is not as obvious, is somewhere between Leilani and Pu'u'o. And so that, is something to keep an eye on. We've heard some reports, actually pretty steadily over the weeks of increased heat flow from these cracks, increased steam. We've talked about how as the magma withdraws from an area, it actually can cause the ground to settle and cause, you can actually have increased heat flow that way. Obviously, you can have increased heat flow as well from magma collecting underground. So the question is, how do we distinguish those exactly? The first thing to me is usually the gas, right? You know, you'd like to see a lot of SO2 to convince yourself that there's fresh magma underground, and you know, that's something we're looking for, right? So when we're looking at some of these images, that's kind of what we're going for. Is like, is there any evidence of sulfur up there? Sulfur is not always easy to see just in the naked eye, so we can look at things like vegetation, you know, how it's affecting vegetation, because steam comes with vegetation more locally. Sulfur is more toxic, right?
Yeah.
So that can leave a larger devastation zone, you know, when you have sulfur blowing downwind,
Right,
right?
and
so maybe you can describe what you told me earlier about the
there's
fissures that opened up and how quickly the vegetation died.
Yeah, so if you look at some of the footage that exists from the Fissure 17, Fissure 16, 20, 22, especially on May 18th, that would be the day when they reopen, and there's just a heavy dousing of SO2 on that jungle. The jungle doesn't die in weeks. It doesn't die in days. It dies in hours. You can see it in a time lapse just go from green to brown. Heavy SO2 just wreaks havoc on these plants. They drop leaves, go brown. So that's one of your ways of monitoring, or at least to gauge how much SO2 is being exposed to a certain area. When you see the surrounding area be still green, it's like it hasn't had SO2, or at least in heavy doses, for a while. We see in Leilani, looking around the more heavy areas, they still haven't recovered. I mean, they've started to. There's buds on like the stalks, trying to revigorate. Some of the more hardy plants have already established themselves and are starting to grow again. But a lot of the damage is they're dead. They're not coming back. So when we look out at Highway 130 and we see green on all sides of the steam, there's not much SO2, and that's just a pretty safe assumption at that point. There might be some trailing. You might be able to go out there and smell that muggy SO2 feel like you'd get at the Moku crack or something along those lines, but I don't see much in the terms of SO2 up there. And the steam line, it doesn't run that far at past 130. Maybe 3/4 of a mile, half mile, 3/4 of a mile, past Highway 130 Malka towards Pu'o'o, the steam just ends. There's, I don't know, you go out there and then you can see the line, and then that's it. So,
Okay.
and over across the Malka of 130, there's not much SO2 damage. Not much the entire eruption, it looks like. There's definitely some, but compare that to what happened in Leilani with the SO2, night and day.
All right, so should we show a couple of these images? So here's one kind of looking uprift towards the cinder cones, back towards Pu'o'o, which you can't directly see, and you guys can see the line of steam right through here, right? So that's kind of what it looked like today. I'm not sure. Oh, here's another one showing steam today once again. You guys can see it's still steaming. Steam often looks a little whiter. You guys can see what we're looking at as far as the trees. We see dead trees right along the fissure line, right? But we see a lot of green on the sides. So this doesn't appear, at least, to those of us without SO2 detectors and using trees as a replacement.
Yeah, it's rough. It's rough. It's a rough measurement, but
Yeah.
better than nothing.
It works in a forested area like this.
Yeah.
I mean, you couldn't do this in the middle of the Kīlauea Desert, obviously. But like in Puna, it might be one of the best things, right? So you guys can see here once again, lots of steam, but nothing. Right, there's a crack, a lot of dead trees in there, but nothing that's looking like a huge swath zone of. Here's looking at Fissure 8, and farther upstream. That may be Pu'o'o off on the background way over there. I'll probably zoom this in a little more here. So you guys can see there is that line of steam.
Well, that's the steam vents there,
Yep.
isn't it?
Going all the way up. Yeah.
Those would be
So-
those primary two that we saw up above.
Yeah.
These are above Highway 130, Malka of it.
Right. So when we're talking about the the possible pinch zone. We're talking about it happening somewhere in here, right? And then possibly between here and here, it might be where it's possibly going to change next, right? And the question is whether it's going to change in a way to actually come out of the ground there, which is what we all worry about. So
Then we have these two.
yeah, okay. So let me see. Let me go back to here. This is one I was going to show you guys. Also, this is one I took on October 4th. So a different day, but you guys can see the line of steam on that day. It's going to see a little rainier, but still, it's been there for a while, this line of steam, right? Maybe, more continuous on some days and others. And probably worth mentioning as well, the effect of the weather.
Yep. The weather, how much it rains, it's going to play how much steam you see. So just rain equals steam. Pretty straightforward. But there's also a little, more subtlety to it, like the atmospheric pressure when it starts to rain, it's going to push the SO2 down more. And so you'll start to, especially in Leilani around the fissures, you'll start to detect it further away. So on a clear day, there'd be no chance about a half mile from it to smell anything. But on a day where it's muggy, maybe the trades are down, you'll catch a whiff. If you're there long enough, you'll catch a whiff. Yeah. And it's really light, but it's still, it definitely depends on how much rain you're getting in there.
Right. Yeah, and one thing I've noticed, not so much here in Leilani, but up at the park, is you can often have steamy days of the steam vents 2 or 3 days after a big rain. Right, so you might actually have a big rain, let's say today, then you might be by the steam vent 3 days from now, and it's nice and clear and sunny. And you're like, oh, it's what a beautiful day.
All of that moisture that
and then
needs to be now. It's
all the
being
moisture
heated.
is in the ground. You just don't.
So
It's
there's
not
delay.
in the air. Exactly. There's
Every
delay in
of
that.
it.
You really see it at Pu'u'o the most, I'd say. Like on some days where after it's stopped raining and it's only been light, it'll be pretty clear up above the crater on the rim. It's pretty nice. You can see the sky and all that. On days where it rains, there's nothing but whiteout, just pure whiteout. Completely can't see anything. Even on the cameras down below, position looking up, it's just whiteout conditions all the way down.
Right.
It really becomes apparent there, more so than Leilani, I'd say even.
Right. So we want to be really careful, basically, when we're looking at the steam, right? And we need to see more data, of changing conditions beyond just steam, right? So
Yep.
we expect some data like that to be coming at some point, right? Because we do know that USGS is watching this area, because it is an area of concern, like we just described, all the whys of that. So we'll keep an eye out on that as well. By the way, speaking of the USGS, tomorrow is the day that their actual now once weekly updates come out. So guys can check Hawaii Tracker website for any updates on that, as it's released, and we'll cover that in our next broadcast, but that will probably be to the end of the week. Unless it's something majorly alarming, that we haven't kind of covered or touched base on that's different and new to all of us. I've got a couple more pictures to show you guys.
Yep.
So let me show you guys this one. This is
Right on Highway 130.
right on 130. Yeah, you guys can see the plates up on the road right up there. Right? And not a whole lot of steam right on the road, but just off the road, you guys can see that area with all the dead trees and white steam coming through it still.
We got a few more. Looking towards Pu'u'o from around 130.
Yeah, great.
You can kind of see the end of the steam line. I don't have my pointer. Basically right up here. These are the ends of the steam. I don't see any more further up.
Yeah.
And then one more look at a little more in depth. This is one of the more steamy areas, Malka of Highway 130.
Yeah.
And you can see how the vegetation in here, if this was SO2 or, moderate or heavy doses of SO2, this whole side would just be dead. It couldn't handle that. But the amount of green in here and around the edges is kind of telling. And that's kind of the best we got right now to work off of.
Well, I think that's great. Yeah, I mean, just kind of, this is an area that we've heard and we anticipate will have changes, right? So I mean, that's something I just want to kind of give you guys
Yeah, definitely.
just a little bit of of status. What was the 4th, like not quite a couple weeks ago, and then today, and then
Right.
we'll see what developments emerge in this area, right? That's the pictures that we got to show you guys.
Because remember on Wednesday we drove through it and there was a lot of steam on the way to Uncle Robert's.
Yeah.
Remember that? There was a lot.
Yeah, and there
coming
wasn't-
back that night as well. It was a lot.
Yeah, and there wasn't
It
much
was almost
today.
a whiteout as we drove across the plates.
Yeah, but there wasn't much
Today
today
it was like nothing.
at that particular spot.
Exactly by the road, but
Yeah,
then behind
exactly
it,
by
yeah.
the road. Other areas definitely steam, but
Yeah.
that was one place that was slightly unusual.
Right.
So yeah, there's maybe one more thing I was gonna ask you guys to talk about. I wasn't with you guys, but you guys went hiking yesterday.
Yeah, so done some hiking around the flows, done some hiking into Po'iki, and just in general, like the flow field is pretty damn dangerous for the people that are inexperienced, even for people that are experienced with just Kalapana. It's a
very
different,
different, isn't it?
It's
Yeah.
a different feel. It's a different vibe out there. Even the areas that look legitimate, like the Pahoehoe, that looks like it's safe. It looks like kind of the Kalapana lava you're used to. It's not as shelly as some of the other lava that's out there. Shelly meaning you can break through pretty easily, thin crust. You still can find those areas to break through, and you almost get lulled into a sense of security because you're looking at stuff that's supported you, 9 out of 10 times, maybe it's 100, out of 100 steps on it, only one fails you. But that one, you almost get lulled into a sense of security where you're like thinking, oh, okay, I understand what it looks like, what's shelly, what's not, just based upon look, and then you fall in a hole.
Yeah.
And it just happens out there, and you look at the and it's incredibly sharp. You're not going to fall through it as you would all the Pahoehoe that's out here, but the is still dangerous in and of itself. It presents a different obstacle challenge, and so
Well,
when
this
you're
has a lot of gaps in it, right? There's
Yeah,
a lot of
but
crevices underneath. There's a lot of space underneath those rocks, right?
Yeah,
That's
it
the
just-
interesting thing. I
it
found.
traditionally doesn't like to pull through. Like it doesn't. You're not going to cave through it like you would the Pahoehoe. The Pahoehoe, you step on it, you think you're fine, and then you're falling. That worse, you step on a piece of and it rocks, and you fall that way.
I can spill you onto it.
Yeah, I
razor
was just surprised
sharp.
at how big the gaps were underneath. Like, although
Yeah.
they're all connected, but there's just lots of spaces.
Yeah, that's kind of typical, right? I mean, it's, one of the biggest dangers I've found flying off flows is actually getting like your foot caught. Like, you have those rocks are loose, and then kind of one rolls onto your boot,
Right.
Yeah,
pins your foot,
yeah.
and you're
Or it gets
falling
jammed
or moving or shifting your balance,
foot
and then
gets
suddenly
jammed
your
and
foot's
it's-
pinned,
yeah,
and you
pinned.
can't get it out, and you twist your ankle or
Yeah.
something like that.
Yeah.
So yeah, those gaps are definitely.
But like most of Leilani is all going to be that shell Pahoehoe. It's the vast majority of Leilani is going to be all shell Pahoehoe. You get down the channel more, you're going to get a mix. You're going to get extra shell Pahoehoe that's gassy and just it looks like glass, but it's terrible to walk on. You'll get stuff that's more beat up and looks a little more like Kalapana Pahoehoe. It's still bad, and then you'll get the on top of it. And it's just crossing between the three of them constantly, and none of those are what I would for tourists and stuff like that. I would recommend not going out there. The trail to like the first part of Po'iki, like the first leg of that's probably as good as you're going to find for walking conditions on this flow. And even that, people have fallen, people have gotten hurt, scrapes all the time, stuff like that. So it's not, there's still an inherent risk by you taking that trail. And you've taken it, and there's still some parts where you're jumping in and, shifting. And
Absolutely.
it's not, a child-safe trail, but of anywhere out there, that's going to be the safest area. It's all that you're walking across, so you don't have to deal with the falling in and just looking legit and falling through. There's not going to be that. Definitely can still fall and get hurt though, and that stuff's like razor blades.
But you weren't there when I was with Harry. Obviously, we were taking pictures, right? And I put my tripod down. We found a hot spot. on that. I can't remember, it was between section 1 and 2 lobes on the Pohiki hike. So anyway, we'd stopped, and I put, he'd been sitting actually in the hot spot, and he was going, "Ooh, Joe, you need to see how hot it is here." And he moved out of the way, and I stood there for a little bit. Then I got lower and crouched down, and I felt this blast of heat coming through the rocks, and I was like, "Oh yeah, that's pretty warm." Felt like a sauna kind of temperature. Anyway, I then moved out of the way, and I wanted to take a photograph of something nearby, and I put my tripod down on the hot spot. And it had only been on the hot spot for maybe 2 minutes maximum. And then I went to pick it up, and it was too hot to touch. Just from that. And that wasn't due to like direct sunlight or anything. That was directly from the hot spot. So that was pretty surprising and amazing, right?
Yeah, it's still very hot out there.
Still very hot out there.
And
That
that's-
was incredible.
Joseph's talking about one of the oldest flows that from this new thing.
Right.
So
It's from one of the
if you
original
pull up to this
flows.
image,
Nope, that's the wrong way. There we go.
so here you're looking up further, you have a ton of different steam coming off of this flow field. This is the hot one. Anything in this area is still going to be much hotter than this McKenzie flow, which is still hot enough to, be very uncomfortable for a person near a hot spot. But out here, this is dangerous hot.
That's Pohiki, by the way, those guys.
Yep.
Don't recognize it.
Yeah, so you're looking at, correct. That's the edge of the parking at Pohiki.
And this is Green Mountain.
Green Mountain.
Polycamaina would be up here where the mouse is.
So yeah, well, one thing I can kind of just elaborate a little bit on is like, why is a Pahoehoe in Kalapana different than Pahoehoe and Leilani, right? So the Pahoehoe in Kalapana runs from Pu'u'ovent on a rift zone down on the coastal plain 4, 5, 6, 7 miles, depending exactly where, and that basically means that you're that distance away from the rift zone. Normally speaking, like rule of thumb that I usually give people when I was giving tours was the closer you are to the rift zone, the more likely you're going to have gas trapped within your flow. And the more gas trapped within the flow, the more bubbly it is, the more shelly it is, the more chance you have to break through it. So that's kind of, there's two things happening there. One is that, you're kind of far enough from the rift zone in Kalapana, down by the coast, where the lava's had a chance to kind of bubble out its gas, whether through all the skylights, out of Pu'u'o, anywhere in that 4 miles upslope of there.
Yeah.
And when it gets to the bottom, you might have some spots that have little shells and little gas pockets. But none of them is probably going to be a yard deep or 2 yards deep, where the kinds that you're going to have in Leilani, right? Just like from the actual fountain of lava producing flows that just have big bubbles within them, right? The fountain's 200 and something feet high, right? But the flow is like 50 feet high, maybe, let's say. Bubble of gas in there could be easily 5 feet high, 10 feet high, right?
Yeah.
It's just that, that makes sense, right? If a flow is only, a meter high, you just can't have a bubble that big in there, more than likely, unless you have a very specialized circumstance. So kind of that's the first thing. The second thing is that it seems like whenever we had these summit collapse events that led to surges, the lava during the surges was extra gas rich. And we've kind of discussed in our previous updates like how this might have actually come to be, what kind of mechanism that actually happened. The point actually is that it was more gassy, right?
Yeah.
We saw changes in the fountain heights. We saw changes in the kind of lava within a channel spilling over the edges, right? We have Pahoehoe overflows from the channel edges,
And
instead of
here's one just
flows
filled.
down the middle. And when you have that much bubbly lava, it means that automatically those spillovers are likely to be extra shelly. Like this picture that Dane pulled up right here.
Yeah.
So.
This is some of the most shelly Pahoehoe you would ever imagine in your life. This stuff is highly dangerous, even though it looks, you can see a little bit of a hole here. It doesn't look that bad. I looked down in a hole in there, and it was at least 15 feet. It was terrifying, considering how shelly that really was. It looks fine, but you're breaking through a foot every step. Every single step. You get over, it's basically you're trying to get to the You're like, please save me, because this stuff is just dangerous. Have to go around it. Anything by the channel is, the closer to the channel and it's Pahoehoe, the scarier it's going to be.
Yeah. So yeah, I mean, kind of one I don't know,
Take
analogy, you know, like
Oh, okay.
I don't know, like joke. I used to say is like, you know, when you walk over like Pahoehoe, it's like playing Russian roulette. Hawaiian style, right? You might have a line of 6 guys in a row, and you might all be walking single file, and you just don't know which of those guys is going to fall through.
Yeah.
Not necessarily going to be the heaviest guy.
Okay.
Not necessarily going to be the first guy,
Right. Okay.
right?
There you go.
You just, you know, that's kind of game you play, right?
Yeah,
you know, maybe
yeah.
not quite as
It's a
fatal,
real lottery, really. Yeah.
but it really is. Like, you just don't know, like, when that, you know, like, you know, person behind, you know, ahead of you shifts that plate just slightly, so it's leaning slightly one way or the other, and the next person steps on it, crack. It's just that simple, right? So,
Yeah.
So this is anywhere next to a channel spillover.
It's the channel
And where
spillovers,
else?
especially the later ones. They're scary. Leilani, the flows around it that look like, you know, a more sturdy Pahoehoe are actually deceiving, because the extra shelly stuff, you can take a stick to it and just boom, boom, and it breaks. And you then know, oh, hey, there's a hole there.
Yeah, easy enough. But
The other stuff, the stuff like more in Leilani, it's going to look legit a lot more often. And it's going to lull you into a sense of security where you think, oh, it's like Kalapana. And then you step on one and fall into your shoulder, up to your shoulders, you know, into a hole. And you don't even believe it's possible until it happens in there, because it feels like a much more stable Pahoehoe than near the channel. That channel, especially down a little ways, you have to experience it to know just how bad it is. I mean, you just want out of it into the most nasty awe field. You're like, yeah, just get me there, because it'll be better than this. Even though it looks fine, and it's deceiving.
have been warned.
so
Yeah.
yeah, so I
Been warned.
mean, yeah, let that serve as a warning for anyone who's, you know, kind of on a fence about where to walk. You know, I mean, you better be really prepared, because it's no joke out there. Yeah, so
Yeah.
as time goes on, and like, you know, it's a little easier to tell, because one thing that happens in these kind of like Pahoehoe fields is over time they do kind of break down, and at some point, like if you go to Manaulu, not that you can right now, but you know, there's shelly lava. I mean, there's, you know, Manau's got its field of shelly lava. Pu'u'u's got one also. Like Manau's is old enough now that you can kind of look at it and you can kind of see like, oh, that thing looks like it's totally pockmarked with holes all over the place. What's going on there? And if you had any doubts, 2 steps into it, you like realize why, and you just take 2 steps backwards and step forwards again. And you're done with that.
Yeah, and
Right,
a lot of this, I mean, some of the areas you could definitely break it down. Like, say you're trying to make a trail through the Pahoehoe, you take like an OO bar out there and just
Right,
pop,
right.
pop, 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 and then, hey, you got a trail.
Right.
Some of those holes are deep enough where I wouldn't build a trail anywhere near it. It's still just avoid it, and we'll find another way.
Right, right. And I'm just saying, like, it's so fresh, it's not obvious.
Oh, no.
Yeah, so it could be that, like, in 20 years, maybe it'd be more obvious exactly what's more shelling and what isn't. But right now, it's especially dangerous as far as knowing what those spots actually are.
Sure. Good advice.
Yeah.
So
Even to the trained, you know, the people who are experiencing it, I think that's the gotcha, as they say, right? You know, just this new, funny, shelly Pahoehoe.
Yeah,
So,
and even guys that, you know, have walked and aren't scared and, you know, go out there and just charge them, they come back and they're just like, man, that Pahoehoe is just so bad in some spots. You just, every step you're breaking in at least a foot. And you just know there's the chance, the Russian roulette, that you actually do fall some amount that you get hurt, and then you're stuck out there. And now what? You have no cell phone signal, because there's no cell phone signals out here anymore, unless you know, have the right carrier. But you know, that's just the way it is.
yeah, it's been proven. There's nothing. No signal. Okay. And are you going to talk any more about Pohiki hike, or?
Not really. Last thing would just be that the temporary flight restriction that we talked about on Friday, that had been placed over Leilani Estates by DJI, and who we figured out to be AirMap, has been decided to be a bug, and the bug has been removed. So the skies are clear again. Basically, there was 3 days that there was an unsupported, no authority behind it, TFR placed in all over Lower Puna for about 25 miles, and now that's just gone. So free skies again, and that was only for drone specific. The TFR, it was just drones, so it wasn't any of the airplanes that have been, or the helicopters,
Right.
beating over Leilani.
Yeah, nothing to do
None
with
of
the
them.
FAA or anything, right?
None of the
That's the thing,
FAA.
right? So it was a real anomaly. We were scratching our heads for 2 days trying to figure out what the heck was going on.
Yeah.
And it just didn't make any sense, right?
Yeah, I'm trying to figure out what type of authority they're using, what's their jurisdiction to be making this type of call, to be placing this type of restriction over places. It didn't add up, and to see them actually remove it on a weekend was good.
That was impressive.
Yeah.
Give them that. Hats off, somebody came in on the weekend and, flicked the right switch to say, okay, we'll remove that.
Yeah.
It was an anomaly, and it wasn't supposed to be there.
From last Friday, it was basically the best case scenario from what could have taken place. We thought we'd be battling for a long time, having to call legal in and all kinds of games to
opposed by
yeah,
whoever.
and instead it was just like, okay, we'll take it away, and then it's gone. So
All's well that ends well, right?
yeah, just let it in there,
All right, so good job, guys, for sorting through that and working it out. Yeah.
Power of social media, I think that one, right?
Yeah.
That one was like, we flagged it, and then it sort of spread around like the world really, and then all the people that kind of had intel on what it might have been, and and then eventually got to the DJI obviously were aware of it, and I guess AirMap were aware of it, being a third-party service provider for them, and speedy resolution.
Yep.
So result.
Awesome. You got anything else to add about the hike or anything else?
Oh boy. No, I think that the heat thing was like a real surprise. The hike isn't as bad as it was initially advertised, although you have to follow the trail. That would be the best bit of advice I could give anybody who's not done it before. Follow the trail. It's marked with coconuts and white pebbles, and
don't make your own trail.
don't make your own trail. Definitely
Don't make your own trail. I've seen too many people out there trying to make their own trail. Don't make your own trail.
And the further away from the coast you go, the worse that will become for you.
Yes.
Right? That's really a place you don't want to go. But yeah, follow the trail, and you can do it actually pretty quickly if you're not like me, stopping to take photographs every 2 minutes. Then it'll take hours because there's so many interesting things to see along the way. And if you can't be bothered to go very far, like all the way to Pohiki, which is worth it, don't get me wrong, but the second beach is a winner. That place is gorgeous, absolutely stunning. Highly recommend that. So I think those would be my takeaways from that. I think it's been well documented. People who've already been to Pohiki, what it's like there, and what's going on, and the surf and the beach.
One thing about Pohiki, take out your trash. The trash cans are full. There's no trash service down there. It's just guys that go in that haul out your trash. So pack out your trash, and everybody wins. We keep the place clean, and nobody has to shoulder the burden basically. Until something access gets established, that's just going to have to be the rules of the road out there. And you see the full trash cans, it's just like that. That can't be. That's not sustainable. People hiking out the trash, that can work. So that would just be one caveat to take away. Is there's no services down there. There's no water. There's no trash service. Just treat it like a camping site, basically, that you care deeply about.
A lot of flies and 2 hawks I saw as well. That was pretty nice too. So 2 hawks flying through the trees.
Yeah, take care of our area, you guys.
Okay, that's it.
Yeah, don't be like trash in the place. Yeah, I mean,
Very important.
that's probably the first act of respect you can have for the place, is to not be trash in the place.
Yeah, totally.
So yeah, thanks you guys. I think we covered plenty of ground tonight. Considering there's no lava coming out of the ground, and we hope it stays that way. There's no reason. No reason to believe it's going to come out anytime imminently.
Yeah, in the short term.
In the short term, it's inevitable. It's going to come out again at some point, right? Whether it's down in Lower East Rift Zone or at the summit, it's still to be determined. Possibly both.
Yeah.
But it's
Some point
only a matter
somewhere.
of time, you guys, right? And in the Rift Zone, it's like guaranteed to happen again, right? It's just a matter of when and where. We kind of hope the when is like not anywhere near here, and the where and a when is like a long time from now. But
keep monitoring for it.
the reality is we have a lot of hazard rift zone designations for a reason, and they're based on the eruption history, right? So, I mean, everyone who lives down in Lower Puna, I think, has, hopefully already come to terms with living in this, with these hazards, because like we've discussed before, everywhere in the world has its own set of hazards, whether they're typhoons or hurricanes or earthquakes or tsunamis, volcanoes or tornadoes or,
Yeah,
other
just happen to
social.
have at least two of those.
Yeah, I mean, we have quite a lot of different hazards here in Hawaii, right? So we should be, if anything, we could come to discussions tonight, we should be more used to it than most people, right? And maybe less surprised by it, right? So, I mean, anyone who's, moving back into Leilani, just has to be just fully conscious of the choice that they've made. I'm not going to judge anyone like you shouldn't do this or you shouldn't do that, but, you do want to be careful that you understand where we are is not going to change our whole lives as far as eruptibility of the rift zone. That's always going to be there, right? But we're not seeing anything happening imminently right now, right? That could change tomorrow. It could change,
I think it's just stay vigilant, but carry on with your lives, right? As if.
Well, exactly, right? So if you're the kind of person that is comfortable living in a situation, then yeah, it's time to, you should have been carrying on already, because you just don't know how long the window is going to be, right?
Yeah.
You hope
Make the
for a
most of it.
60-year window.
Yeah, make the most of it.
But, you might be like, okay, well, maybe I have a year, and then next year you might say maybe I have another year, and next year you might say maybe another year. So after 60 years of that, you might have your 60-year window, but it's not going to be like right now, well, you have 60 years to go, right? There's that security or stability just doesn't exist in zone 1, right? It's just like the kind of hazard you have to be comfortable living with, which I believe many people are. I've talked to lots of people who are. I have no problem, being in Leilani, so that's great.
Hey, we're in Leilani right now.
We're in Leilani right now, right? And we're not looking over our shoulders every 2 seconds, right? Because, we have...
We are 1 street away from Fisher 8, and when broadcasting this, we're fine, not scared, we'll know, we're prepared, basically. There's not... The people of Leilani, the people of Lower Puna, Kapoho, Noni Farms, there's not a sample size of people that exist on the earth that have more experience at this point at this type of eruption. There's a ton of experts out there now, especially in how to evacuate, what to grab, what to look for. We learned the hard way on how to do this. And now that we've gotten through that, if it were to happen again, people are much better prepared than the first time where everybody was scrambling and panicking.
Yeah, for sure.
There's no way to match that type of panic the first few days and the first month where everything escalated. Now,
I'd say the biggest threat right now is the rain. Because there's so much of it this week, it's driving me nuts.
all right.
Sorry. On that.
Yeah, that's all.
So, all right, you guys. So thanks for joining us. Thank you for a reminder, Burr. Hawaii Tracker is actually has another donation drive. We do realize that everyone who is in Puna does not have the means to be, supporting us. So we're not asking you guys by any means, right? Ideally, any of you guys who are watching from off island, that might have any resources that you would like to see us continue this kind of work, not just myself, but the whole Hawaii Tracker team, especially Dane, who does all the nightly updates, right? And Ryan and Sarah, yeah. I'm not sure who else wants to be mentioned by name, but we'll maybe leave it at that.
Ken Boyer, there you go. I said it.
So, all right, calling you out, Ken. In any case, it's a great team. We are kind of looking for some kind of longer term solutions. But as it is now, it's really interesting to be part of it seems like a movement where people are actually getting their information in different ways than you might have gotten them.
Right.
10 years ago, even 5 years ago or so, so this is kind of a model that's being put to the test right now.
Yep.
So if this is something that is been useful, highly, and you have the means like we just discussed, highly encourage you to kind of keep this thing going, because there is a traditional way to do things, which everyone really knows how that goes, and we want to keep this up. But we're still in a kind of tenuous time where it still has to be proven, and the way that it gets proven is by our audience actually endorsing us and supporting us to do it more. At least until we can find the longer term paradigm that makes it work, right? Without having to go into advertising where we have to really sell clicks, right?
Yeah.
Which is something we really want to avoid doing.
Avoiding the traditional media model as much as possible.
Right, so not spamming ads and that kind of thing, which is the tried and true method,
Yeah.
and what's not the way that
But distracting for the audience. So yeah.
distracting, and maybe not quite
So the one
as rich in content.
I'll just
perhaps,
break it down like this. When you listen to the media, you're getting no analysis, you're getting regurgitated. USGS said X, we're going to just paraphrase that at best, most likely just copy and paste it. But that's the amount of laziness. You get a paraphrase, you get a copy and paste, that's about it. And when you look at what the confines are around the government agencies that release information, they have to use their own sources. They're not going to be able to go out and be like, oh, look at social media. It's obvious on social media there's 50 videos up of X happening. They have to go and independently verify it. To us, that's a waste of time. You can verify those types of things on the fly based on crowdsourcing, based on referencing, criticizing sources on the fly, establishing their validity, cross-checking data. That's going to be done, in real time. And we've kind of tried to show that during this eruption. Whereas the traditional models, they cannot keep up with that type of pace. They're not designed to keep up with that. They don't scale as well. They're not as adaptable. Whereas we can adapt on the fly to that model of the volcano to a hurricane. And there's not much of an issue. You just change the data sources and the methods stay the same. And that's where we're different.
It can apply actually to any kind of news, event that's going on in the world, actually. And that's certainly a model that I've already tried to start to implement on my side of things as well. But, when it comes to a natural disaster, or anything political, obviously there's a potential for roadblocks to be in the way there. But even still, what we proved through this experience in the last, few months since the eruption was that in spite of all the restrictions, a lot of really great data was brought to the community and was correctly filtered and self-policed and fact-checked for accuracy. And even when there were errors, which there's always going to be some element of error, right? I was really impressed by the way it was rectified quickly by the community and the people involved in the data gathering, right? And it just kind of worked without actually needing a particularly institutionalized structure, dare I say, right?
Yeah.
It's kind of worked.
I'm going to try not to dive into it too much, but basically what it is it's a secondary source. So like when the lava channel was running and a lot of people were thinking, oh, it's going like 40 miles an hour, it's going fast, right? We did our analysis and we were able to say, okay, it's doing like 17 miles an hour, which is incredibly fast for a lava channel to be running at that kind of speed. And that's faster than you can run. That's incredibly fast.
I might have been
When-
guilty of that.
When later when USGS comes out and they say, oh, it's doing 17, which they did do. The ability to have two sources coming to the same answer using completely different methodologies, they support each other. But it's also not being scared to say, yeah, we don't see that. You can say that all you want, but we don't see the data to support that. And it gives a cross-reference, basically. for
Honestly speaking,
everything.
from that, can we just talk about that lava speed? No?
It's already going too long.
Okay, all right. But anyway, maybe another time.
Yeah.
But I mean, that one I still think is quite contentious. I saw that thing moving way faster than 17 miles an hour.
I think you're wrong.
So yeah, we'll leave it to this, right? Let's go to the big parking lot
Yeah.
and let's drive a car at 17 miles an hour past you,
Yeah.
and imagine it's lava.
But that's what I was doing when I was figuring it out that it was definitely going faster than 17. I was saying 30
No,
minimum.
no way.
because I see the car go at 30 miles an hour, and I thought,
Yeah.
we're talking at the fastest point
So,
in that lava channel.
I really don't want to go into it, but since you're going to drag it on, all you have to do is you know the exact distance of Leilani Avenue. You know how wide it is. So all you have to do is you get somebody that's like plays a bunch of video games, for example. They're really good at leading objects, especially with time delays, as you get with the mouse. So you have them do it, click on one side, click on another. You don't trust one sample, you trust 25 averaged out. And then you give a standard deviation to that, and then you have your answer. The average was 17.5, and the guy I was having do it was an 18-year-old kid that plays video games all the time, and he was able to hit it to within 1/100th of a millisecond, the speeds. And at that point, it's like, yeah, I'm comfortable with this speed. And then for USGS to come out the next day and just be like, yeah, it's within a half mile an hour of what we were estimating. It's pretty
And
safe
we're
to
talking
say.
about that
Yeah.
section just there.
Yeah, at its fastest point.
That was considered the fastest point.
Yeah.
That bit crossing Leilani Avenue.
Crossing
Just,
Leilani.
Yeah, that was considered one of the fastest points, if
Okay.
not the fastest.
all right.
So it's just that.
I'm still going to look back at my video. I don't know.
Go ahead.
This.
Yeah, and then do this like go in a parking lot and like run away from a car going 10 miles an hour.
Mm-hmm.
It comes faster than you think.
Mm-hmm.
Just
Yeah, it's just fun. Just a fun thing to
for
end
sure.
on.
Yeah.
For sure, yeah. So yeah, guys, as you guys, as Libby points out, the common thread between whether it's a hurricane or a flow or measuring this or that is really the people, right? So like that's what we're asking you guys to support as the people.
Yep.
So thank you guys for everyone who supported us already. We know that a lot of you guys have done that. So just kind of encourage you guys. I've had people mention to us before that. It's just like a subscription kind of thing to them, right? It's
Yeah.
like getting a magazine or subscribing to Netflix or like,
Instead of getting Sports Illustrated, you get Hawaii Tracker.
yeah, could be the Wall Street Journal, maybe not quite the Wall Street Journal, but maybe if, for Puna,
Yeah, exactly.
Puna style, So anyways,
Yeah, I think that's what
that's our pitch for that, yeah. So thank you guys for bearing with us for our longer than anticipated update, which is great. We just, glad we have so much to share with you guys, and
Yeah.
until the next time.
Until next time.
Which
That's
will-
what happens when you bring in guests like me to like distract you from all the different topics you plan to talk about. Sorry. Hope you
no
guys enjoyed
worries.
it anyway.
All right, guys. So
I don't want to say anymore because I might be accused of like making this update go
I
on too
think
long.
it was.
say, tell us your last thing, your sign off. Yeah. What's your word of wisdom for the evening?
Stay classy, Puna.
All right.
Yeah, we'll just go with the tried and true. Stay
Stay
classy.
classy, Buddha. All right, you guys. Aloha.